Ladies and gentlemen, it is with great pleasure that I introduce to you Professor David Egelman from Brown University, where he did his bachelor and his degree in medicine before doing his MPH at Harvard University. Dr. Egelman has been for a very long time involved in public policy related to the protection of health of workers, and this is what got him on the asbestos beat, if you pass me this expression, and he should be credited with the care he has brought to the study of this question, which has permitted to identify a certain amount of problems, that you will present to us this afternoon. Aside of the eminence of his position in public health and occupational health, Dr. Egelman has founded and is still the president of the board of directors of an organization called Global Health Through Education, Training and Services, a nonprofit organization dedicated to improving health in developing countries through innovations in education and service. Dr. Egelman has thus completed or almost invested all sectors of public health that matter, including how to join those populations who are underserviced. He has a very substantial message to bring today, and so is the case for the second speaker. So we will run very, very short on time. I will ask Dr. Egelman to start and introduce the second speaker later on. Thanks.
Okay. I guess before I start, I just wanted to make a brief comment about the poverty comment, which bothered me for most of the morning, because I wondered why we would all be here, since it would be more efficient in terms of helping people if we could all improve poverty. And so I'll give you a quote from Darwin on that tries to allay the two issues. If the misery of our poor be caused not by the laws of nature, but by our institutions, great is our sin. And so the idea is that there may be parallels in seeing what happened and what happens with asbestos and corporate influence, and why there is poverty. Because after all, if poverty was profitable, it wouldn't exist. Now, a little bit about me. You've heard that part. I'm an expert witness. I testified the request of companies and workers who are injured. I actually was a consultant to Scott. I answered that question about vermiculite. And I'm at the Warren Alpert School of Medicine. We have to use that name every time we introduce ourselves. We don't have to do this. Warren Alpert was the president of Grey Goose, and for $100 million, he got his name on every member of Brown's faculty stationery card, etc. You only have the Bronfman building. Hats off to McGill. This conference is one of the best examples of openness and self-analysis that ever occurred at a university, in my view, in large part because they allowed me to come talk. Okay, I'm going to talk about four things, and you can buckle your seatbelts because we're going to go fast. First, some history of asbestos to try to give you some political and social context. Then a discussion of dose response, which was the key to the issues that you heard this morning. How much asbestos does it take to hurt you? That's the key to determining whether or not asbestos can be used safely or not. The third, the argument that tremolite is the hazard, not chrysotile. And fourth, some recommendations about the university corporate interactions. I'm here to evaluate scientific findings, mostly related to the McGill research that was mostly performed under the auspices Dr. McDonald, who came here in 1964. I'm here to share the reasons corporations gave for funding research in general and that research in particular. I'm not here to question the motives of the scientists. I am going to be talking mostly about statistics, but as Dr. Selikoff, the leading asbestos researcher in the United States, famously said, statistics are human beings with the tears wiped away. Am I in the right place? Well, in 2002, I sent a complaint to Science arguing that data had been omitted from papers submitted by McGill faculty to Science indicating that tremolite, not chrysotile, was the the cause of disease, and therefore chrysotile itself could be used safely. Science wrote back, the institution where the researchers did the work has the authority and the responsibility to deal with such situations. So we're at the right place. McGill's response to the first letter I wrote to McGill in response to Science's letter was a review, two reviews, one in 2002, another one by Dr. Fuhrer last year, and then finally a consultation report to determine, all three would to determine if there should be a review under Rule 5.42, which is the formal mechanism for McGill to review research integrity questions. So the formal review has not yet occurred. There have been three reports that have indicated that no formal review is necessary. Dr. Eidelman, when he received the review, said it is his conclusion that faculty does not currently have all the required records and data to assess definitely in regard to research integrity. That has not changed. It is my view if you don't have the data, the burden is on the researchers to prove what they did and said is correct, not on me. Nonetheless, I believe that the available published data statements and other information indicates that the data that was published in the series of papers that culminated in 1997 with a statement that said that exposure to asbestos was essentially innocuous in the Quebec mining group is not supported by the material that they used to make the conclusion. Therefore, it is not over. Now, to go to the theme of the conference, the purpose of a corporation, the social responsibility of business, is to increase profits. The purpose of a university, in my view, to promote the advancement and dissemination of knowledge that enhances happiness. That's from Thayer Ablund. Okay, now you can make your own definition of happiness. He doesn't define it, it's a problem. But it's not just, I would argue, the dissemination and acquisition of knowledge. There is and must be a purpose. You can have an evil purpose to the dissemination of knowledge. So purpose is important. Some history. The lady inspectors, and they were female inspectors, and I regret to say there's only, I think, one female speaking today, but in England they had female inspectors. Most of the workers in textiles were women. They were called lady inspectors in 1898. Lucy Dean noted, quote, this is an report to Parliament, the evil effects of asbestos in any quantity have been noted. It's important to recognize that the mines in Canada were owned primarily by British and American companies. The workers were not. They were francophones. So things that went on in England were known to the owners. In 1918, American and Canadian insurance companies refused to insure asbestos workers here and in the United States because of the assumed health injurious conditions of the industry. In 1926, McGill first enters the picture when they're approached by one of these insurance companies, MetLife, to establish an adequate Department of Industrial Hygiene so that they could collect data on information relating to health of industrial workers. Such a plan involves a definite quid pro quo. This is from the MetLife data, no indication McGill ever knew about it, till now. Pedley from McGill did a study of Thetford mines in 1930s, the first study of those miners with respect to disease. They found 24 out of 54 had pneumoconiosis. Pneumoconiosis, as you learned this morning, is the general term for all dust disease. Asbestosis is a subset. If you get pneumoconiosis and you're exposed to asbestos, it's asbestosis. A lot of the papers refer to it as pneumoconiosis, but if it's in the miners in Canada, it's asbestosis. There's no talc there, there's no silica. Pedley asked to get permission to publish the paper. Permission was refused as part of the quid pro quo. The data is available through litigation. Now, moving to the United States, in 1935, there were over $100 million in lawsuits against MetLife's insureds and others. Many of the companies faced bankruptcy. This is the middle of the Depression. This was a real problem. MetLife organized a meeting to deal with the problem in Pittsburgh, founding the Industrial Hygiene Foundation to both describe and deal with the problem. And the problem was described in a speech by a lawyer for Owens, Illinois. Silicosis is a very real ailment, and at the present time presents our greatest industrial hazard, which, if not properly controlled, will result in the financial ruin of many companies. Now, he did invoke a biblical quote. You should be concerned not only with the successful defense of your own cases, but of others as well. In this situation, the answer to the age-old query, am I my brother's keeper, is emphatically yes. Each verdict against a defendant encourages others to bring suit. I'm not sure the current Pope would interpret am I my brother's keeper the same way at the present time, but that's how it was. That's a long time ago. Okay. Sure, the Bible's changed since then. It's Old Testament anyways. The solution that they came up with was to create standards, which, if complied with, whether or not they worked, if there was a number, they could say there was a number. And they would be able to defend the lawsuits with that by saying, well, there was a number, we thought it was safe, therefore we don't have to pay. What if there wasn't a number? In 1933, the chief inspector of factories published a paper saying, if the slightest exposure to dust results in death, the use of asbestos will have to be prohibited. The preventive measures can be summed up as prohibition. So this is a serious problem. Coming back to Canada briefly, the Canadian strike of 1949 was the most important event in Canadian politics in the last century. I didn't say that. That's a paraphrase of Pierre Trudeau. The only book he ever wrote was on the asbestos strike. What happened during that strike is the Catholic vote split. Many of the younger Catholic priests, Catholics were supporting the Conservative Party, split, and the Liberal Party, Trudeau included, gained prominence. This is non-trivial. There is politics involved from inception. Ivan Sabran was the lawyer to QAMA. He was also the head of the Conservative Party of Quebec. The owners, as I mentioned, American and British, the workers, Francophones. Okay, in 1958, the Quebec Asbestos Mining Association, which is a mining association of the Quebec owners of the mines, conducted the first study on lung cancer. And this is what they found. Results show that a miner who develops the disease asbestosis does have a greater likelihood of developing cancer of the lung than a person without this disease. Copies of this were numbered and returned. This is what was published in the medical literature. On the basis of what seemed to be complete and reliable data, it seems fair to conclude that the asbestos miners in the province of Quebec do not have significantly higher death rates from lung cancer than do comparable segments of the general population. The reverse. Now, don't worry, this was corrected quite rapidly. I published a letter in 1998. Okay. Now coming back to Canada and McGill. In 1965, after Selikoff had a conference in 64, with about 1,100 people, he got a lot of publicity around the world talking about asbestos health effects. There were no government regulatory agencies to impact onset. All he could do was try to get the New York Times and other papers to cover the problem. QAMA responded. They recognized and followed what they considered to be the tobacco model. They came to Quebec. Their purpose for coming to McGill was to retain authoritative background for publicity. I'm not saying that was McGill's understanding, but that was the company's understanding. Now, dose response. The research depends on dose response. The higher the dose, the greater the response. They needed to know how low the dose could go before you could say that the hazard had gone away, or vice versa. Dose, and I show many colored pills, and that's because there were many different particles measured when they measured the fibers and the particles together. McGill's conclusions, there was a high dose required to cause disease, therefore standards should allow high exposures. Chrysadal does not cause injury when used properly. And finally, not that many workers die from exposure. Okay? That's the words this is from their final paper summarizing about 40 years of research. Thus, it is concluded from the viewpoint of mortality that exposure in this industry to less than 300 million particles per cubic foot years, and I'll try to explain that, has been essentially innocuous, although there was a small risk of pneumoconiosis or mesothelioma. The only two responses they considered were pneumoconiosis and mesothelioma. You heard earlier today, I think, lung cancer is probably something that might not be omitted. Okay, I had a slide here on asbestosis, but you now know what that is. Innocuous, well, this is also from the same paper. Men whose exposures will, innocuous, by the way, is not a scientific or a medical term. It is a relative. In other words, when you say high, you need to know what low is. Innocuous doesn't mean anything by itself. It has to be compared to something. There's no standard comparison. It's not a scientific term, but that was the term in the abstract, and that was the term that went around the world. Men whose exposures were less than 300 million particle fibers per cubic year suffered almost one-half the deaths, less than 300. And there were 146 total deaths out of 8,000 from pneumoconius and mesothelioma. Okay, only about 1% or so. Here's the reason the dose data was problematic. The workers were exposed to fibers and rock dust. In the open pit, they would explode the pit. So the fact that, just so there was no intendedness, just so you understand that, although the tremolite is separate from the chrysotile, in the mining process, it is contaminated with tremolite because it's exploded. Okay, so the dust in the air has both fibers and dust. A particle year's exposure to 1 million particles per cubic foot. That there's a cubic foot carton. Okay, fibers are measured in fibers per sugar cube, cubic centimeter. There is no way to convert. So when you're basing your measurements on the box, you can't say anything about what should go in the cube. Why do I say you can't convert? Well, because that's what McDonald said several times. In 1976, he said that in the Baudry Commission, by the way, the Baudry Commission was set up so that the workers would give up their demand to be able to walk off the job if exposures were over 5 fibers per cubic centimeter. In exchange for giving that up, they got a commission to study asbestos health effects. Okay, and he testified that their efforts, McGill's efforts, because it was more than him, fizzled out in terms of converting fibers to particles. And if you can't figure out what the dose is, you cannot come up with a scientifically justifiable dose-response curve. It's not science. This is what he said again in 1980. Determination of the, this is in a written document, it's available at the Tobacco Archives, it's not published, that I think it was one of his reports to tobacco, but I'm not sure. Determination of the equivalence of these measurements is difficult and dubious operation. Even in chrysotile mining, the range is at least 40-fold. In other words, if they found 1 million particles per cubic foot, that could represent 1 million fibers or 40 million fibers, and you could not tell the difference. You cannot develop a dose-response curve when you don't have dose data that's more accurate than 40-fold difference. And why? The midget impinger was the machine they used. The midget impinger could only count total particles. It couldn't tell the difference between dust and fibers. Okay, so if a fiber's a Maserati and a Ford is dust, you're looking at the road there and counting the total number of cars. You can't tell which is which. If you're at a Maserati dealership, mostly they're going to be fibers. If you're on Rue René Lévesque, mostly they're going to be dust. You can't tell the difference from this technique. Now, was this known? Well, there was a paper given in 1969 by Dr. Rendell on dust measurement techniques in South Africa. McDonald was there. He asked this question: can an inaccurate instrument like the midget impinger give an accurate result? Let me read that again. He doesn't question whether it's an accurate or potentially accurate instrument. Can an inaccurate instrument give you an accurate result? It's not a very good scientific question. So it was known before. He was answered. The midget impinger is the wrong instrument on which to base standards. Of course, a watch is correct, broken watch is correct twice a day, but you wouldn't want to judge a race based on a broken watch, and you wouldn't want to tell people how much asbestos they could be exposed to based on a broken standard. For example, this is my scale. It's stuck at 120, and you can see the results. Okay? All right? Now, furthermore, that wasn't enough. They actually did side-by-side samples. In 1974, they published side-by-side samples, and they found 100 fibers per cc could be 2.5 million particles per cubic foot, or 2 fibers per cc could be 33 million. And this is from their conclusions. Read the last sentence. For 31 out of 86 samples, the linear correlation was close to 0. You could do better with darts. And in general, overall, it was only 13% better than a conversion obtained at random. 13% better than random is not how you base a standard for exposure. Okay? Now, at WTO, McDonald said the opposite. He claimed his dose conversions were accurate and could be relied on, particularly compared to the ones that you just heard Les Stainer talk about at Charleston. Here's another problem. Where didn't they measure the dust? First, and how often? They almost measured dust in every mine once a year for all the miners and all the jobs in that mine. Almost every year. But they didn't take any measurements in the open pit and maintenance departments, and only a limited number in the underground mines. The underground mines are in the central part of Thetford. I think it's a reasonable guess that the underground miners had higher exposures than the open pit miners. This is just because of the talk I added this slide. It was hidden before. These are the proportion of fibers. When those fibers go away, as you heard talked about this morning, they leave the lung in that math model, and they go somewhere else. Well, one of the places they go is the pleura. This is a study from 1974, no politics involved here, from France, and this is the relative proportion of fibers in the lung, in the pleura, not the lung. Okay, and okay, so here's 5, which is the cutoff, and you see most of the fibers in the pleura are short. And by the way, they're mostly chrysotile in people with mixed exposures. Okay, this idea about thin fibers was not discovered, with all due respect, by NIOSH in the last 5 or 10 years. This was known by Selikoff and published in 1975, that thin fibers don't get picked up by light microscopy. Now let's look at response, because remember he said the exposures were, you could tolerate high exposures, and he limited the response to pneumoconius mesothelioma. What did he actually find? Well, there were 561 cases of COPD and pneumonia in those miners, deaths. None were attributed to asbestos. There was 657 cases of lung cancer. None were in that assessment of what innocuous was. None. Okay, now, let's do a little bit on synergy a little more. Okay? If you expect 1 case per 1,000 in a population, no exposure to smoking or asbestos, asbestos will give you 5. This is from Selikoff's data, roughly. Smoking will give you 10. Together, you'll get 50 to 100. That's synergy. So how do you decide if you have 100 cases of lung cancer, which caused which? Well, here's one way. 5 are from asbestos, 10 are from smoking, 85 are from both. If you take the 5 asbestos, add it to the 85, you get 90. If you eliminated the asbestos, 90 out of 100 are from the exposure. Now, you can do it in the reverse, too, but these are workers who are unknowingly being exposed to asbestos. I think it's fair in terms of compensation and other things to give them the benefit of the doubt. Okay, so what's the real number about attributable to exposure in the mines? It's 713 deaths, not counting the COPD and other deaths. And by the way, there were 10 TB deaths as well. Those are not part of the non-malignant respiratory disease. 10% is not innocuous. Okay? Now, how did it present the data as innocuous? Well, what they did was they said, with the asbestos exposure, you got those mesos and pneumoconiosis, and the SMR changed from 1.06 to 1.07. How about diabetes? You think that's innocuous? If you do the same thing with U.S. diabetes deaths, with diabetes, the rate ratio with the SMR is 1.03. Without diabetes, it's 1. It's only 75,000 deaths out of 2.5 million from diabetes in the United States. It's innocuous based on this construct of innocuous. Innocuous is a political term, not a medical or scientific term. Let's look at the results when in the final paper. The actual results. Okay, this is a quote. When they looked at the exposures, that's the 13 exposure, but they've taken at face value. Now, what scientist would ever take their data at face value? Okay? It would imply a protective effect of exposure. In other words, when they looked at the actual data based on the dose estimates, the dose estimates were worse than what I said. They actually were inversely related to risk. So the higher the exposures, the lower the risk. Okay, so they fixed that in the appendix. They explain how they fixed it. So this is what it really showed, the actual data. Actual data. Okay? Higher exposure, fewer mesotheliomas. Okay? This is a quote. Admittedly, they deleted all the data points that showed asbestos was protective. They just deleted them. They didn't delete them based on they were outliers or was a contaminated specimen. They deleted them based on how it impacted on the results. They said, incorrectly, that there was a degree of arbitrariness. Now, arbitrary is generally not what you call good science. When you self-characterize your science as arbitrary, that's not generally praiseworthy. Okay? But it was unfortunately not arbitrary because they threw data out because it gave a wrong result. And they said that. They said, see, they kept the doubts, they kept the results when they were significant. Significant what? Significant. Significant based on what they thought the results should be before they did the study. Okay, and you heard already, you saw Les talk about McGill's results were an outlier. Okay, and there's other people who said that. The consultation report, however, said that they were not an outlier. They were consistent with others in the research committee. Whatever the reason, they were not consistent. Now, a little bit of tremolite. The idea about tremolite was there were central mines that had high tremolite exposures, peripheral mines in Thetford that had low exposures. They didn't report which was which. I wrote to Science. Science asked Dr. McDonald for the data. He said he wouldn't give the data because he had confidentiality agreements with the companies. Science considered the names of the locations of the mines essential data for that. Now, they published it anyway. It was a letter. They published it. But they consider that data essential. Not me, Science. Okay? There are no confidentiality agreements that I've been able to find, and all those mines were bankrupt at this time. They were legally dead. Okay? So McGill generally reported 15 mines. The consultation report found 12, but the consultation report couldn't tell which were central, which were peripheral. Okay? Remember, Science called that essential information for the research. Not me, Science. How many mines were there? A lot more than 15. This is a map of the asbestos corporations just in Thetford. I don't know if you watched the Bellevue Hillbillies up here, but you know everybody had an oil drill in their backyard. To get oil in asbestos, everybody dug a mine in their backyard, hoping to strike it rich. So there were hundreds of mines in Thetford. Everybody wanted one. Okay, and they all amalgamated, but there were not 15. Now, how did you know which was high and which was low tremolite? Well, 3 papers say Sebastian in a 1989 paper, which actually was a paper that compared tremolite levels from Charleston, which they used Quebec asbestos, to tremolite levels in the lungs of workers up here. 3 times they cite Sebastian's paper that he compared tremolite levels in the worker lungs central versus peripheral. We couldn't see that in the paper. We read it, maybe we're dumb. So we wrote to Sebastian, did you do this? He said, no, he didn't do this. You're correct, this point was not addressed in my 1989 paper. So the data of high and low tremolite mines doesn't exist. No one can find it. Sebastian said it isn't in the paper they cited for it, and he just says, I didn't do it at all, because he refers us back to Dr. McDonald. There's another explanation for why there's high and low levels of meso, central and peripheral, 2 actually. The peripheral mines were newer, lower latency. Also, the central mines had 3 underground mines, higher exposures. In their papers, McGill researchers say, well, we took into account the exposures were the same. How could they do that? They had no exposure measurements in the in the open pit, and only a few. How could they know the exposure was the same? 1 sample a year. Can't know it. You can't say that. In the end, the impact, by the end of it, this is from McCullough Tweedale, who wrote a book about the global asbestos industry. By the end of the 20th century, the McGill scientists had presented the world with a product that was whiter than white. The impact regulations were blocked, sales were maintained, and workers and families were uncompensated. And this is still a continuing impact. I'm not here because I like Montreal. I like coming here, but I'm here because this is still important. These studies are still used to justify sales in developing countries. Okay, it impacted on the Simpson report. They cited McDonald's data. The Ontario Royal Commission banned crucidolite and amosite, but not chrysotile, and they relied on McGill data. McDonald traveled to Brazil, this is in terms of sales, and was quoted in the newspaper saying use of chrysotile was safe and you could have very high exposures. Okay, when I testify in lawsuits, the defense experts always use the McGill data. They say, this guy was working with brakes or joint compound. That's nothing near the exposures of the miners and millers, and they don't have any cancer. How could this guy's cancer be from that? People lose. I asked 3 questions in the recent letter complaint. Was the data manipulated in terms of removing arbitrarily data points? Not addressed. Where are the mines? Not found. Addressed but not found. Where's the Sebastian data? Not addressed. So there's those data, I think I can try to convince you it should be rejected. The response is not innocuous, and the tremolite, the mines are missing. The McGill science does not support the conclusion that chrysotile is essentially innocuous or innocuous. McGill should retract the study. It's the burden of the researcher to produce the data, not the critic. Okay, finally, corporate-funded research. In general, all research is conducted on people, sometimes people in groups. In this case, money should have been given to the workers, the unions, to hire independent experts, to consult with them, to evaluate the protocols, and to participate in the research as outside advisors to the workers. The workers, and this probably would have made it better research, by the way, should have been involved in the process of designing and conducting the research. Same thing's true for drug research. If you're doing corporate-funded pharmaceutical and medical device research, there should be an independent group evaluating that research. Harlan Krumholtz is doing this at a model at Yale with Medtronic. Admittedly, it's because they got caught with their hands in the cookie jar, but nonetheless, there is a model for independent people doing independent evaluations of research that's corporate-funded. The data should be retained. That's kind of obvious. I think that's already one of your rules. And the data should be blinded and made available to outside researchers. The EU has proposed this for drug research. I'm going to only do 53 of the 56 recommendations the American Association of University Professors have made regarding corporate and university relations. I would just leave you with one, actually. The researchers and not the company must control the data and perform the analysis. This is not the norm in drug research. The norm in drug research is the data analysis, all controlled by the company. The researcher who signs the paper gets the tables, doesn't participate in the analysis. Okay, and what to do when research is challenged? I'm happy if you do a 5.4.2, but I think investigations and investigators should be independent of the institution. Again, thank you for an